Welcome back to this Walking Talking mock. We're doing Further Maths, paper 1 from 2012. And we're on question 9. So we've got some thirds in a ratio, and this ratio question is a million times easier than any ratio question I've ever seen on a Churchill paper for normal maths GCSE. So I'm thinking we get lucky if we get a question like this. Right, let's try and simplify all these thirds. So 12, okay, 4 times 3, so that's 2 root 3. 48, that's 16 times 3. And 300, that's 100 times 3. So it's 2, 4, 10. I can simplify that once more though. 1, 2, 5. So that will be the answer. Alright, we've got a kite. Work out the equation of A to C. A to C, okay. Well, okay, that's easy. I can just do rise over step. Okay, rise is 4 over step, which is 12, but it is negative, so it's minus a third. So we've got y equals minus a third x plus c. So I'll put in, well, wait, the y-intercept is 4, so plus 4. It's easy. Work out the coordinates of B. Right, let's see. This is perpendicular, so the equation of BO is going to be, so the gradient will be 3, because it's the negative reciprocal of minus a third. I can see that the y-intercept of this is 0, so it's just going to be y equals 3x. Oh wait, I don't even need to do this. What am I doing? Let's just do this with like common sense. So actually no, I do need to do this, because if I can find that coordinate, then I'll be okay. Let's find that coordinate. That's where these two lines meet. So if I make the two lines meet each other like that and solve it, so I get 3 plus a third, okay, that's 4 thirds. Divide by 4 times by 3, so that's 3, and what's the y coordinate going to be? It's 3 times that, which is 9. Wait, what? No, it's the y is 3 times x. How is that 9? That's not 9. It's not 4 thirds. It's 10 thirds. Yeah, because 3 is 9 thirds, and now the next one is 10 thirds. Oh dear, okay. So 10x is 12, so x is 12 divided by 10, that's 1.2. So that is, what's 3 times 1.2? 3.6. That makes more sense. Okay. So, to go from here to here, it's gone across 1.2, up 3.6. So if I did the same again, I've got to go across 1.2 and up 3.6. So that's going to be 2.4, 7.2. My advice, whenever you've got something like this, like a kite or a rhombus or a trapezium or whatever, they like this kind of question, don't always think that you're going to have to be using, like, I don't know, proper methods or like geometric methods. Well, this is geometric, but a lot of the time you can use a bit of common sense and a bit of like counting. You know what I mean? So don't, for example, I know we've got some diagonals here, so you might be thinking, oh, Pythagoras, I got a right angle triangle, I don't know. But always see if you can do it in like rises and steps, you know, like vectors. Always see if you can do that. Right. A graph passes through 0, 0, the rate of change of y with respect to x, which is another way of saying what? dy by dx. Is always a half. So, in other words, the gradient is always a half. If the gradient is always a half, then it's always the same gradient, constant gradient. So, it's like y equals a half x. And it passes through 0, 0. So it's just y equals a half x. So if x is 1, y is a half of that. If x is 2, it's half of that. And join it up. Like that. Okay. A graph passes through 1, 2. The rate of change of y with respect to x is always 0. So the gradient is 0, so it's flat. Whoops. Right, draw from 0 to 4. So I should stop there. Did the other one say when to stop? It did, it said 0 to 4. Oops. I don't think you'd lose a mark for that. Oops, I've gone the wrong way. Hang on. Is that right? Y equals 2x cubed plus ax, where a is a constant. The value of dy by dx when x is 2, ooh, this is a spicy one, is twice the value of when it's minus 1. Okay, let's work out dy by dx first. So that's 6x squared plus a. And when x is 2, let's put that in. That's 2 squared is 4, times 6 is 24, so 24 plus a. When x is minus 1, it's 6 times minus 1 squared plus a, which is 6 plus a. Okay, and that is twice as much as that, so 24 plus a is twice as much as 6 plus a. So 24 plus a equals 12 plus 2a. So 12 equals a. A must be 12. And then you could just check that. So 24 plus 12 is 36. 6 plus 12, 18. Is 36 double 18? Yes, it is. Simplify. This looks very similar to what was on your GCSE paper 2, I think it was. Right, so simplify, of course, means factorise. So I'm going to go to town here, factorise everything. That's going to be a single bracket, isn't it? So it's just... Okay. So times together to make 12 and add to make minus 4. That's going to be 6 and 2 plus 2 minus 6. That is a Mr. Howell special, so that's x plus 5, x minus 5. That's just x plus 6. And that the common factor is x minus 5. Okay. Right, so now what we're not going to do is expand those brackets, Jordan. We're going to do KFC, which I'm still calling it KFC, even though I absolutely hate that expression. I don't know, it's just kind of stuck for some reason. So I'm flipping that over, and now we're going to times. Can I cancel anything? That should be plus and that should be minus. Stupid. You know, the reason why I knew that is because if this was minus, then I wouldn't be able to cancel anything. So that's kind of like a hack you can do. If you don't know how to factorise something, bear in mind that there's got to be something that's going to cancel. So you can always kind of like fiddle it around a bit. I'm going to cancel that and that. And when I cross these out, I'm making sure they're still legible, because the examiner needs to mark what's underneath your crossings out, because you can get credit for it. I'm going to cancel that minus 5 and that minus 5. Okay, so I've got x minus 2 on the top, and I've got x plus 5 on the bottom. And that is my answer. And I'm not going to cancel x and x here, because that would be completely stupid. X is not a factor of the bottom, only x plus 5 is a factor of the bottom. Right. X to the 3 over 2 equals 8. Y to the minus 2 is 25 over 4. What can I write x over y? Okay, so should I just... X over y is... Alright, no, let's not be too clever. Let's just do this the simple way. If x to 3 over 2 equals 8, so something cubed and square rooted makes 8. So I'm going to do the opposite. So this has been square rooted, so let's square it. And then this has been cubed, so let's cube root it. So x is 4. Do the same thing over here. This is to the power of a minus, which is like 1 over, it's like reciprocal. The opposite of reciprocal is reciprocal. Reciprocaling is like an inverse function of itself. Okay, this has been squared, so I need to square root it. So x over y, 2/5, no, 4 over 2/5 is the same as 4 times 5 halves, which is 20 over 2, which is 10. 5 marks for that? Maybe that wasn't as easy as I made it look. I don't know. Further maths is, you know what, it's so much nicer than maths. Although maybe they'll make it different this year, because maybe they're going to try and make it more similar to normal maths by putting in stupid like Griselda is having a barbecue and tiling her shower and making 420 cakes. Okay, right angle triangle. Oh, I like this kind of question. Use triangle XYZ to show that sine 60 is root 3 over 2. So I showed you how to do this, but they gave you the triangle, so that's nice. Right, so I know that that is 60 degrees. Seeing as we're looking at sine of 60, I should ignore the 30 and focus on the 60. Let's label the triangle. Because I'm focusing on this 60, not the 30, this is going to be A. So sine of 60 is the opposite over the adjacent hypotenuse, which is, oh, I should find this out first, Pythagoras. Square root of 2 squared, take away 1 squared, which is root 3. Which is root 3 over 2. Well, that was... I barely even showed that. It was just kind of like obvious, but it's because you're going to get 1 mark for that and then 1 mark for saying O over H, I guess. Right. ABC has an obtuse angle at C. Given that sine of A is a quarter. Okay, so I'm thinking I should be using, because I'm interested in this angle and they've told me something about this, I'm thinking sine rule. Also, they already told us that sine 60 is root 3 over 2, so it's definitely going to involve sine. Okay, so let's see. Sine A over that equals sine B over that. Okay, sine A is a quarter. So a quarter over that equals that. Should we just times everything by 4? Or no, let's times this fraction, the top and bottom, by 4. So well, let's do it separately instead of with brackets. So I'll make that 8 minus 4 root 3. I'm going to need a bit more space, I think. Okay. Now I need to times both sides by 4 root 3 minus 6. Equals sine B. Okay, I want B to be 60 degrees, so I want sine B to be root 3 over 2. I'm going to have to fiddle around with this. I think I should rationalise it. So let's do that over here. 4 root 3 minus 6 over 8 minus 4 root 3. Okay, so I'm going to times it by the conjugate of the bottom. So I'm going to make the surdy bit the opposite sign. Because that's minus 4 root 3, I'm going to make that plus. Okay. 4 root 3 times 8 is 32 root 3. 4 root 3 times 4 root 3 is 16 times 3, which is 48. Minus 6 times 8 is minus 48. Nice. Minus 6 times 4 root 3 is minus 24 root 3. 8 times 8 is 64. 8 times 4 root 3 is 32 root 3. Minus 4 root 3 times 8 is minus 32 root 3. Minus 4 root 3 times plus 4 root 3 is minus 16 root 3, so minus 48. Okay, so on the top, 8 root 3. On the bottom, 16? Yeah, 16. Okay, which equals, divide by 8, root 3 over 2. So, sine theta will equals root 3 over 2, so theta equals 60 degrees. Shown, because they gave you the answer already. Alright, I think we've just got one question left. So this is going to be a two-parter. I was expecting it to be 3. Oh, nice. We've got a trig proof. So tan theta plus 1. So because it wants me to prove this, I'm going to start with just the left-hand side. And I'm not going to even really look at the right-hand side. I'm just going to jot down the thingies. So it's sine squared plus cos squared equals 1. And sine theta over cos theta equals tan. I'm guessing we're just going to be using this bottom one because I can't see any squareds. So let's see. Let's change that sine into tan into a sine over cos. And let's change that 1 over tan into a, well, this is the reciprocal of tan. So the reciprocal of tan would be cos over sine. Hang on, I need water. Okay, now to add these together I need a common denominator, so let's make the denominator cos theta sine theta. So what have I done to this fraction? I've times it by sine over sine, so that's going to make that sine squared. Ah, I see. What have I done to this fraction? I've times it by cos over cos, so that's going to be cos squared. And cos squared plus sine squared is 1, so I end up with that. And of course I've written it backwards like an idiot, so let's just fix that. Oh wait, equals right hand side. So it's proved. Excellent. By the way, if you've got any questions about further maths that you would like me to answer, please put them in the comments of either this video or the previous video, and as long as you do that before 6:30, I can do a video response and I'll post that as soon as possible. Okay, I'll see you next time. Bye!